American Indian Smithsonian Institution, and welcome to our project, Hapagñan, Road of the Inca, and this session of our Good. Well, welcome to the National Museum of the American Indian Smithsonian Institution, and welcome to our project, Hapagñan, Road of the Inca, and this session of our satellite broadcast of Research on the Hoof. You're witnesses to an experimental approach to research and to the presentation of research, as our museum explores ways to bring the experience and observation of our scholars and researchers directly to audiences here and throughout the web world. On the hoof, in the revelatory process of the field experience, we often learn in fresh and immediate ways. The learning is intellectual, but it is also visceral. This is an experience we want to learn to share. And we have a growing team of field researchers as well as technical folks presently who are helping us. One caution for our audience, we're still getting familiar with the technology involved, so bear with us. And may the Apus and the Pachamama open our way and our channels today. This live, via satellite, interconnective session with NMAI and allied researchers today from the Peruvian Andes investigates the fascinating road system of the Inca Empire, an extensive network of approximately 20 to 30,000 kilometers of roads that entwine to an estimated 100 provinces and some 6 million people, encompassing territories throughout the extensive, monumental Andean and coastal landscape of Chile, Argentina, Bolivia, Peru, Ecuador, and Colombia. The Hapagñan, or the Inca Royal Road, defined the largest of American hemispheric polities, indigenous polities, which until 1533 extended from its center, the navel of the empire, Cusco, in the southern Peruvian Andes, to its four quarters, the Tahuantinsuyo, the four-corner empire. The NMAI Hapagñan project is multi-layered and multidisciplinary. It involves symposia, museum collections, seminars, in-the-field examination of research and archaeological, historical, engineering themes, as well as ethnographic documentation with contemporary Andean indigenous communities. Today, we focus principally on engineering themes and questions. An important theme to consider, the concept of sustainability. How did the Inca build such sustainable structures, including the features and techniques of the Inca Road itself? In what ways and to what measure did the Inca engineers consider and apply the laws of nature? Even how could modern engineers learn from the Inca techniques? The reading of the landscape, water flows, anti-seismic design. Again, what of their practices could support modern engineering practice? Today, we are joined by an extended team of colleagues live from the field at two sites along the Inca Road, one from its center in the area of Cusco and the other farther straight up north from Lima on the long road to Quito at Ancash. Today, we go to the team at Ancash, and I'm going to introduce now Dr. Edward Jaselkis, Jimmy D. Clark, Distinguished Professor in Construction Engineering and Management at North Carolina State University of Colorado at Boulder. Over to you, Dr. Jaselkis.
Okay, thank you very much. I'd like to welcome everyone on this webcast, and also like to thank our sponsors, the Smithsonian Institute, as well as the National Science Foundation. Without their support, we would not be here today. What we're doing, in a sense, is our group, our engineering group, is trying to understand how this great Inca Empire designed and built such a great road system. And in our studies, starting last summer and this summer, we've really discovered a lot of really interesting features, design qualities that the Incas incorporated into their road system, related to the road itself, how they drained water from the mountains to basically not affect their road, retaining wall structures, and I think we may have found a dam as well that we'd like to share with you today as part of this broadcast. What we'd like to do is start with introductions with the rest of our group here in Ancash, and we'll have each person stand in front of the camera and just make a brief introduction of themselves so you can basically see what our team consisted of. The slides that you're going to see in the PowerPoints that follow really were a result of our whole team working together on sketches and taking measurements and photos and whatnot. So let's go ahead and start with our team introductions. So let's see, how do we want to start? Chris, you want to just come up here first?
Hi, my name is Christine Beckman, and I just graduated from the University of Colorado at Boulder, and I am proud to be a member of the engineering team here in Ancash.
Hello, my name is Lim Manoka Munachalan from Thailand. Currently, I'm teaching at Chiang Mai University. I am also in the engineering team. I'm in charge of creating models.
Hello, my name is Gerardo Chang. I am a professor of the Civil Engineering Department of the Universidad de Piura, and I am a member of the engineering team.
Hi, I'm Aldo Diaz. I'm Peruvian. I'm studying engineering, civil engineering, at the University of Piura, and this is my last year. And also, I'm working in a company. And thanks.
Hi, I'm Maria. I'm from Argentina. I'm an architect, and I am in the engineering team.
Hi, I'm Daniela Alarcón. I'm from Chile. I'm an engineering student. I'll be graduating this year at Universidad Católica.
Hi, I'm Davis from Canada, and I'm helping out with production and geomorphology.
Hi, I'm Megan Sun. I'm behind the camera most of the time. I'm a writer, filmmaker. I also know the road quite intimately because I've walked basically the entire Highland route between 2005 and 2007. And I think our guide, we have Andrew.
Hi, I'm Andrew. I'm from Taiwan and doing GIS and GPS in this team.
And I think we want to introduce Basilio.
Buenos días, mi nombre es Basilio Trujillo Zorrilla, de la provincia de Huari, de acá 20 kilómetros. Estoy con el grupo, ya estamos caminando el día 6. Bueno, estoy apoyando a ellos como guía. Muchísimas gracias.
I'm Basilio Trujillo. I'm from 20 kilometers away in Wari, and we're in day 6 of the trip, and I'm helping as a guide.
And we should just say that without Basilio, we would have had a much harder time.
Absolutely. Well, if you want to know exactly where we're located here, Megan's going to do just a slow pan of the surrounding area. This area is called Puak Hirka. I hope I pronounced that correctly. The reason it's called this is because it means there's seven peak mountain, and you can see some of the peaks of the mountains right now. In terms of our geo coordinate location, we're at south 9 degrees 10.291 minutes and west 77 degrees 11.049 minutes. So if you want to look us up on Google Earth, you can do that and see exactly where we're located. In terms of elevation, we're still up pretty high at 4,281 meters. Today, after the broadcast, we're going to pack up and actually start heading back down to where there's more oxygen. And it'll be a little warmer too. So at this point, we've got a PowerPoint presentation that we want to show you that will summarize essentially our whole trip, starting several days ago in Tambo and where we are today. So we'll talk about all the things that we found from an engineering perspective and share them with you. So we're going to set up in our little tent here right now. If you just bear with us, we'll get set up and we'll start the PowerPoint presentation.
They're doing that just to give you an idea. They are closer to the equator than the Panama Canal. But you've got to realize you're in the southern hemisphere, so it is wintertime down there, and they've had some very cold weather. It's also at about 14,000 feet, so they're high up in the Sierra there.
Right. Okay, so Cliff, is going to be changing the PowerPoint slides for us, so appreciate your help there, Cliff. The first slide title of our presentation is Reverse Engineering the Inka Road, and we're going to be covering our whole trip. If I'm out of breath still, every time it seems like I move around or walk, I start getting out of breath up here. I still haven't gotten adjusted. And I do have a slight cold, so apologize for that. Anyway, let's go to the next slide. As far as the outline for our presentation, I want to show you a little bit more about our current location using the GPS equipment that we have here. Again, go over our goals and our obstacles for those people who did not see our webcast yesterday. And then basically we'll kind of go over our findings from the start to finish of our trip. And then we'll go outside of the tent and we'll show you some interesting features about this part of the road, and then show you what we think was an old dam that failed. So that's and then we'll wrap up. So that's basically what we'll be covering for today. Next slide. Next slide just basically shows a picture of our group. This is at the top of a pass we took a couple days ago, and that rock structure that you see next to them is called a apacheta. So next slide, you can see our total distance traveled on this trip from Lima is 707 kilometers. The first part of our trip was in like a minivan or bus, where we went up into the mountains up to a certain point, went to Juarez, a town called Juarez, and then from Juarez to our hiking point, the Tambo, we had to take four-wheel drive pickup trucks because vans would not do very well on that kind of road. Then from there we just have been hiking, and it's probably been about 30 or so kilometers that we've hiked so far. Next slide. As far as our goals as a team, our team in Ancash as well as the Cusco team, we want to understand how the Incas designed and built this incredible road system that we've been hiking on over the past several days. And we also are experimenting with this technology we call teleengineering. So we're able to bring our engineering findings to you in real time, live, and allow you to be able to ask us questions and get, I think, a more complete experience of the engineering findings that we're discovering here in Peru. One of the things with teleengineering, in the past when we've done these webcasts, people, are maybe a little shy in asking questions, but if we have the ability to zoom in with the camera or zoom out or move the camera, if you see something of interest, tell us and we can move the camera and you can get a better look at something that you think might be very interesting. So you may wonder how we move all of our equipment around. The next slide shows the animals that have been really helping us out a lot. There are several llamas that are used for carrying the lighter loads, our personal gear, backpacks, etc. And then the mules are carrying the heavier equipment, like all the satellite equipment, like the generator and the antenna, etc. And all of the cooking supplies and tents. Yeah, it hasn't been easy to do these broadcasts. We've run into lots of obstacles that we can describe as logistical, technical, and physical. Logistical is just being able to transport all of the equipment and gear that we have and the food and shelter for about 15 people in very high altitudes. And on the first day, our first hike, well, first of all, our animals didn't show up on time because their truck broke down. And so Basilio was able to round up about 5 mules from local farmers so we could get our gear to the hotspot and broadcast to you. And at that time, we almost lost one of the helpers who fell into a ravine as he was trying to retie some ropes on equipment on one of the mules. So he fell into the ravine. 2 of the crates fell into the ravine and completely got smashed, and we lost some of the food for our trip. And then technical issues, batteries that run out because of the cold, or we have to just keep charging them a lot. Satellite communication issues that are beyond our control. There was a storm in Miami that basically knocked out the teleport for a little while, so we lost satellite communication, things like that. And then the physical side is just dealing with the altitude, because most of us are not, used to these kind of, heights, and so there's less oxygen, and when we walk from point A to point B, it just takes more time. Anyway, and also the cold temperature. So many of us are sniffling and have stuffed noses, and you can hear people snore a lot at night too. Sorry. Anyway, so those are some of the obstacles that we face to bring, this live transmission to you. Next slide. Some of the girls on our trip put this little schematic together showing our starting point at Tombo over on the left. And I don't know, Cliff, if you have the capability to kind of move your mouse cursor starting at Tombo, and this almost looks like a board game of some type. But anyway, showing where we saw the Ushnus, and I'll show you some pictures of those, and then saw some interesting hydraulic jumps on a very steep section of the road. The slope was very, very steep. And then the Apacheta. The Apachetas are found at the top of the passes, which are just stone structures. And I understand that travelers are supposed to put another stone on the Apacheta for good luck as they travel. We found a quarry then. There's lots of paving, but one of the things that I didn't realize is I thought the whole road would be paved with stone, but it's really not. It's only the areas where it would need to be paved with stone, and those are the areas where you have to deal with water issues. And then we went on to this Tambo Barakaya, where we saw some corrals for the animals, kayankas, and also residential structures for people who would be living in that Tambo. We've also saw lots of stairs, okay, and I'll show you some of those, what they look like. And then these chaskiwasis, which are little like house structures and for the runners. The chaskis were runners who would run almost like sprint running from one chaski to another, which was maybe about 2 kilometers. Messages from one chaskiwasi to another. And wasi means house, like casa. We then went through an area yesterday. We got some rain. It was very cold. And you can see all those little blue lines, and it says culverts. That was an area. It was almost like a floodplain zone or a swampy area that the Incas had to construct their road through. And how did they do that to still preserve the road? Well, there were culverts every maybe 10 feet or so in order to shed the water from one side to the other. We saw something very interesting that we hadn't seen. I didn't see this last summer or this summer up to yesterday's walk, where we found a curved wall section. So we'll show that to you. And then we're finishing up basically here in Puakirka with the 7 mountain peaks. And we're going to finish up our hike in Huari Tambo in another day.
I would just like to add something. I think that the route that we've taken this year is quite important because it's very indicative of what the road is. I mean, the architecture of the Inca Road. We have traveled from Tambo to Tambo with a stop in a Tambo in the middle. Between these Tambos, often you'll find chaskiwasi, you'll find apachetas, and all of these are indicators that we are on the Royal Highway. The chaskiwasi that is on this modified map is not the only chaskiwasi that we've seen. In fact, yesterday we crossed another one after leaving Payawachangan. So,
Megan, tell us again, what's the chaskiwasi?
Chaskiwasi is a small house, I guess, to to keep a runner while they're waiting for the other relay runner to arrive. Some of the chaskiwasi that we've seen are at high points, so you can see standing in one chaskiwasi, you can see the next chaskiwasi in the distance, as you can see as well the apachetas. So there is an architecture of the road that is very important, I think, to understand how it functioned in the time of the Incas. Over.
Let's
this. The tambo is, a rest area. They can vary in size. We saw some small ones. We saw some big ones. The ushnu that we crossed are, ceremonial platform. The apacheta, as Ed described, is just a marker, usually at a pass, where people give offerings to ask for safe passage by, putting a rock on it or actually making a small offering. The chaskiwazi, which is what we've just described, and then the kayanka, which is usually located and found in tambos, are a long rectangular building used to house people for the night. As well as to, it was a place of reunion. It was a place where people could have meetings, a place where people could have trade, and a place for people to sleep as well. Over.
Okay, so Cliff, if you could advance the slide then, appreciate that. So this next slide is essentially our first camp spot near the first tambo that we were at. That just shows you a picture of that. And then the next slide, as Megan was talking about these ushnus that we saw two small ushnus near the tambo, and you can see the GPS coordinates and the altitude. And basically these ushnus were they were kind of deteriorated a little bit. But if you go to the next slide, the next slide gives you a sense for if you're standing in the middle of one of the ushnus, what would the scenery look like all around you. So Lim was able to set up his camera tripod right in the center of one of the ushnus and take a panoramic picture, 360-degree view. And that's exactly, if you are standing in the middle of that ushnu, that's exactly what you would be seeing in terms of the view. The next slide, it shows kind of the ushnu orientation. There were two ushnus that we found. One was 12 meters square and the other was 11 meters square. They were separated by about 21 meters with the road going between. And everybody we've talked to said that the orientation of the ushnu was true north. And we also found other structures like kayankas, for example, where they too were oriented in the same true north direction. So there's something, and I'm not an expert here as far as how they determined true north at that time, but that's what the people were telling us. Basilio knows a lot about this area, and that's what he was saying.
And just to add as well the importance of the ushnus, Cliff might be able to add something here too, but the ushnus, they are ceremonial platforms. Ceremonies are held here to pour chicha into the center of the ushnu to nourish Pachamama. Basilio told us that in these ushnus in particular, the people from Yaoya still come up and perform their ceremonies there. Over.
What's the question? Could you repeat your question, Cliff?
Yeah, the road, the road construction, every year, every community, man, woman, and child that was able to do, except for the very old and the very young, had to put in a certain amount of time of tax to the state, which would be through working, whether it would be weaving, whether it would be road construction, whether it would be, building of different sites. And, in the times of the Inca, these roads would have been in pristine conditions. We found, obviously, examples where the road still holds, but many examples, which we actually will see later today, where the road has fallen into disrepair because, for reasons that, we don't really know, people are not coming up here and repairing them as they would have in the times of the Inca. Over.
One last thing on the ushnus. What they did was, in terms of building the ushnus, they typically built a perimeter wall first, and then they would fill in the center with small stones. And as Megan was saying, they would pour chicha, which is fermented corn, through the small stones to basically nourish Pachamama, Mother Earth. So anyway, that's what we have on the Ushnus. Then we continue on. Just to give you the next slide shows Chris slowly walking up a pretty steep grade of the of the road, and so we just wanted to basically how difficult it is to get around here. Going to the next slide, on a really steep section of the road, we noticed the drainage. The way they drained water from one side of the road to the other was not just to let it drain onto the slope, because the slope was so steep that they were concerned that the water, with its velocity, would just erode the slope very quickly. And so what they did was they put these little hydraulic jumps or steps at the end of the culvert going down the steep slope, just to keep breaking down the energy, the amount of erosion caused by the water. So this picture just kind of shows you a few of the little steps there, and Daniela, one of our engineering team people, put together a cross section of the slope. And so if you look at the next slide, it shows the cross section of this drainage area and how big the jumps were. And you can see that the slope of this area was about around 30 degrees plus or minus. And we noticed that the road itself, the steepest part of the roads, were about 11 degrees. So this was a pretty steep slope that they had to control the water on, and they essentially built steps, like I said. And you can see that in the cross section. Okay, going to the next slide. It says Apacheta, and here's a good picture of a couple things. You can see our whole caravan. They seem to walk about 3 times faster than us. What would take us 5 hours to walk, they could probably do in about an hour and a half to 2. But anyway, that was one of the things I wanted to mention. The other is the Apacheta. We're approaching a pass, as you see, and that little rectangular structure at the top of the pass is the Apacheta. So let's go to the next slide, and this just shows more hiking with a good view of the mountains in the background. It's chilly up, so please repeat your question over.
Cliff, we can listen to you. Only Ed can hear you because you are in the private channel. You have to go back to the public tab and then use the mic.
Ed, do you hear us?
Yes.
Yes, I hear you.
I'm looking at the straightness of the road. Can you comment on that?
The road itself, in terms of the slope, what we found that yes, the roads were pretty straight, and the slope varied anywhere on average from about 5 degrees to 8 degrees in slope. There were some instances where it pushed to about 11 degrees, but for the most part, yes, the roads were straight. We did see some, like this one area where there was a curved retaining wall. There was a kind of a sharp curve in the road, but for the most part, the roads out here that the Incas built were straight in about a 5 to 8 degree slope. Over.
Ed, what are the snow-capped mountains I'm looking at in the back of that picture?
You know, does anybody know the names of those snow-capped mountains? I don't know. Don't know.
It's all part of the. Oh no.
Okay. All right. We can get that information later. We've got a topo that has the names of all the mountains here. Let's go to the next slide. Okay. Let's go to the next slide. That's at the top. It says road and quarry. This particular section of road we found to be extremely well preserved. I mean, there's good sections of road, and there were really poor sections of road that we saw, but this section in particular was really well preserved because there was a stone quarry right above it that basically, protected the road from the water. And what Lim was able to do was develop on the next slide a point cloud of this particular section of road, and then created a tin model of that part of the road. And then from there, the next slide shows the texturing. This is the actual texture of the road itself that was put into the 3D model that Lim created. So wanted to kind of give you a sense for what the road looked like, or what it would have looked like 700 years ago for the Inca, because this was pretty much left intact, not changed. And you can see the different size stones that the Inca used, kind of like a puzzle. And there was, I don't know, I guess we've talked before about gaps between the stones. We haven't really studied that, whether there was stone on stone contact or whether there was a gap purposely put in there. We haven't really talked much about that. But anyway, this gives you a good idea of what the true Inca road looked like. Okay, next slide. This actually shows that same section of road, but it gives you a better view of the quarry that's right above it that's protecting this part of the road. Next slide. This shows a tambo at Maracaya. There's actually 3 structures in here. There's a cayanca in the upper left-hand corner of this photo. On the right side, you can see what people say were corrals, but there's kind of some uncertainty about that from our standpoint. And in fact, we made a broadcast from those corrals a couple days ago. And then right in the middle, you see another, what looks like a structure that we think is like a residential structure for people who lived in that area. So this tambo, and maybe Megan can describe, what is a tambo, and then what is a cayanca. I'll just ask her to do that right now.
Yeah, so just to repeat again, the tambo, they were spaced, Hislop says they were spaced, anywhere from 20 to 25 kilometers away, basically a day's walk. I think we've kind of shown that on the road that we've walked. We walked from Tambo to Tambo Maracaya. It was about 20 kilometers. From here to Wadi Tambo, it's probably about 20, maybe a little bit less. And these were places where people could rest that were traveling on the road. A cayanca, which is in the top left corner, is a common feature of tambos. You can see them, I've seen them as far down, you see them as far down Argentina, Bolivia, Peru, Ecuador, and they are meeting places or places for people to sleep. In this particular tambo, Basilio tells us some of the local knowledge that he has, that it was used for trade. From the surrounding communities, people would come and meet here and do their trade. And thus, perhaps, the structures on the right side, which have been defined as corrals, could possibly be rooms, just from the size of the walls and the height of the walls that we studied. Over.
Okay, let's continue on with the next slide. Daniela made a little sketch of the cayanca that you saw in the previous slide, and it shows you in terms of the dimensions. It was 26 meters long, 8 meters wide. We weren't exactly sure of the height because it was many of the stones had fallen off the walls. One thing interesting that she found was if you look at a cross section of the wall, you see AA there on the left side. It showed that the base of the wall was wider. It was like 1 meter, and the wall itself tapered off toward the top, and she measured about 0.7 meters at the top. So it was wider at the base, and it narrowed toward the top. So let's move on to the next slide. This shows the structure next to the cayanca, which was probably some kind of a residence for people that lived there. And this shows you the schematic of that, and you can see the dimensions in there. It's a fairly large structure, 9 meters plus 25 meters, so 34 meters by probably about 16 and, is that 10 meters?
Yeah.
16 and maybe 23 meters or so. So this is not to scale.
Ed, could y'all tell which way the doors,
slide.
no doors going into that courtyard area?
part.
Not really, Cliff.
It's difficult to tell.
It's difficult, yeah. Next slide shows one of our camping spots. Where was this camping spot? Help me.
Tumbo. Those are the tumbo.
Okay, that was our Tambo camping spot.
The tumbo's just above us.
The Tambo was just above, as Megan was just saying. Next slide. We'll talk a little bit about the slopes, some of the steps we found, and the road width. Let's go to the next slide. This shows our GPS tracking from Lima to where we are right now in Puak-Hirka, and you can basically see most of this graph is really by motor vehicle, whether it was by van or whether it was by pickup truck, four-wheel drive pickup truck. So really, our hiking started way to the right, where you see our first broadcast at elevation 3,803 meters. Follow that line over to that little hill. That's really where we started our hiking, right about in there. Actually, it's right below in the Tambo. That's really, so everything to the left is all by motor vehicle through the mountains, and then everything to the right is all hiking. And so if you go to the next slide, you can see this is now an expanded version of that little slice you saw in the previous slide, from Maracaya, Tambo to the Paya Huanchangan area. You can see the slopes that we were able to calculate, ranging, as you see, from about 5 degrees on the low side for the slopes to 11 degrees on the high side, but on average it was about 5 to 8 degrees slope for the roads. As Cliff was alluding to, the roads were pretty much straight. They tried to keep them straight as possible. Even if they had to go through a swampy area, that was no problem for the Incas. They basically designed and built that road system to manage that swamp, to keep the lines as straight as possible. Next slide shows our hike that we took yesterday after the broadcast. We packed up and went from Paya Huanchangan to here where we are here in Puak-Hirka, and you can see where basically we have come down a little bit in altitude, but we're still up pretty high, still pretty cold up here. Next slide. Talking about the steps, there wasn't any one consistent step design that we found. It really varied. Here's an example where you see the picture below of the steps. In the lower left-hand corner, you can see the steps. And then the engineering team basically measured out the steps and found these steps had a rise of a pretty constant rise of about 0.2 meters and a run of 0.7 meters. And in this area, there wasn't any natural stone that they could use as part of the step, so they just built it the way they wanted to, and also to fit the slope. The next slide shows a different kind of step. Here we're approaching a pass. It's kind of steeper at the top, so you can see that there's more steps closer together, and in this case the rise was a little bit shallower, and maybe because it was steeper. So here you see the rise is about anywhere from 0.05 meters to 0.15 meters, and the run kind of varied a little bit here too, that you see from a low of 1.7 meter run on the step to 3.7 meters. And you see, if you go over to the left a little bit, so 17 meters, and then you see a little drop there, a 0.15 meter drop. We believe that it's not a step like the ones on the right. This is like a step to slow down the water as it comes down that hill, just to reduce the velocity and the energy that has cut on the amount of erosion that you're going to see on that road. So the Incas designed, they were very careful about dealing with water and trying to reduce the erosion effects from it. Let's go to the next slide. And here you see this is actually the road that we showed you yesterday on video. And one thing, the road is well defined by walls, stone walls on either side. That's how you know this is the Inca road. And many areas are paved like you see here, but many areas are not paved. There's just the wall on either side, and it could be just, hard soil in between, no stones. Let's see, were we going to do a model of this one?
Later with the
Okay. Okay. Here's another example of a road. You really can't see this here, but there's a retaining wall structure on the right side, just below where those two people are standing. And there's also 2 drainage channels in the road because this section gets a lot of rain through it. Go to the next slide. Next slide. This was our campsite in Payo Wangachonkan. And here's a beautiful view of our campsite that we wanted to share with you. And let's go to the next slide. And our broadcast yesterday was actually from this hill. This is Payo Wangachonkan, and Lim was good enough to create what we thought would have been what the structure looked like at its time without the roof on it. We didn't want to try to speculate how they built the roof, but based on the ruins that we found, we recreated a 3D model of what that stone structure would look like. And this area again, there's a story that an Incan princess gave birth, and it was possibly in this particular structure, this exact structure. Go to the next slide, and here we are hiking after we left the broadcast yesterday. It started raining. The clouds came up, it got cold, and it started raining. And here we are on part of the hike coming to our current location. Next slide. Retaining walls. There were lots of retaining walls on this stretch of the road, and they varied in height anywhere from very short heights, 0.35 meters, to 2.8 meters, maybe even higher in some places. And we believe that the Incas were able to tie, especially the taller retaining walls, into the rest of the road structure using kind of an interlocking rock formation or rock pattern that you can see on the next slide. And on this slide you can see how they build up the wall, one width of wall, and they get up so high, maybe three rows of stone, and they'll put another stone across that goes into the road section. So it helps tie that wall into the road so it doesn't collapse. Next slide. This was very interesting. We came to all the retaining walls that we've seen up to this point were straight, and we came across a retaining wall structure that was actually curved. So we spent some time trying to study its characteristics. This retaining wall is actually built on top of a natural rock formation, so it has a really good foundation. And we were able to calculate what the radius of this wall section was, just based on measuring the curve length on the outside of the wall, and also the chord length for that same section, and found out that the radius was 7 meters, and the angle on the inside was 64 meters. So this was kind of interesting because we'd never seen any kind of a curved retaining wall up to this point. And even in fact last summer when we were hiking other parts of the Inca Road, I don't believe we saw any curved wall sections like this. So this is kind of interesting and different. Next slide. So this is the apacheta that we saw yesterday, just as we were coming over the pass and then looking down the valley. And at that point we were very close to our campground area. The photo in the lower left-hand corner shows the 7 peak mountains. That's the name. Puacurca means seven peak mountains. Next slide. Let's talk about water control. This particular stretch of road we took yesterday had lots and lots of water control, and there were really 2 kinds that the Incas used. They used a closed drainage approach that you see in the picture on the right-hand side. And this was actually a well-preserved closed drainage channel. The closed drainage channels that we saw in the past several days were actually were plugged. They were clogged and they were not functional. This one was in really great shape, and we thought this would be a good time to do a 3D model of this particular drainage channel that you see on the right here. So Lim Lim got his camera out and tripod and started using some photogrammetry techniques to develop a 3D model of this particular drainage structure that he's going to show you right now on his computer. So we're going to have to actually, as you see on the camera, you can see it hopefully coming in now, and Lim will do some rotations and show you the 3D model.
So I think on the left are the pictures that Lim took. He has to take a series of, I don't know, 10, 20, 30 pictures to try to do modeling. And on the left side, you see the two pictures that he took at different angles. And then on the right, the actual model of the canal, of the culvert, which with more work would be filled in. But based on our limited time, we've come up with this, which I think is pretty good. As you can see, actually the depth of the canal as he turns it around.
Yeah. And what the engineering team found was that the depth of these types of closed channels were about 0.5 meters, and their width were about the same, a little bit less, about 0.4 meters. So I'll give you an idea of the size of that opening. There were also a number of open channels, and we've got pictures of those. We've got an open channel right next to us that we're going to show you that's not in the best of condition. But water control is critical for the Incas, because there's a lot of water here, and water can be very destructive to a road. This next slide shows you well, a couple things here. The picture on the right shows you another channel, except this is an open channel to drain the water from one section of the road to the other. It's kind of deteriorated, as you can see, but that's an open one. The open ones essentially have two sets of stones. It's like a wall on one side and a wall on the other side, and 20 centimeters in between. That's what the engineering team measured, and I asked about stones on the bottom. They said no stones. The picture up in the upper left-hand corner is looking down on a closed channel, but you can see the gap in there that we're actually able to put our measuring devices in and measure the depth and also get the width of these closed channel structures. Going to the next slide.
You and Megan might want to mention who used the road, and that's why you can have these open channels that way.
Well, the road, from what we know, it was used primarily for the Inca state. So it was used by the military, it was used by llama caravans, it was used by nobility and the chasquis, governors, whatnot. I don't believe, from what I've read, that it was used by the common person, except if they were on state business. So, the road, in order to be kept kind of at a level, to be a very smooth surface, in order to make it comfortable to walk long distances. And I guess these covered channels, were to avoid having people fall in.
Yeah, road strictly for a llama, an animal, and a man walking with a sandal, so it's easy to step across these open culverts.
Good point. Okay, well, Cliff, could you go advance to the next slide, please? This next slide shows a schematic of a drainage wall. So in this particular section of the road, there's a hill actually right behind the road, lots of water coming off, and so the Incas built two drainage channels, as you see here. The road was, 5.4 meters. They had two drainage channels. We also discovered that the Incas put like a rock backfill behind the wall to also help the water drain through the road and seep out through the rocks of the retaining wall, basically to try to minimize the amount of water pressure behind the wall. We saw, where they did it properly, the walls were intact. Where water was not drained from behind the wall properly, we saw many walls just blown out because of the hydrostatic water pressure. We also believe that these drainage channels that they put into the road were tied, somehow the wall was tied into the road structure with the drainage channels, but we really couldn't investigate that because we couldn't do any excavation. On the next slide, Lim again shows you a 3D model of one of the drainage channels on that schematic that you just saw. So this is a schematic on Lim's computer. He could actually do the rotations. Anyway, let's go to the next slide. And here we are coming into our campsite probably about, was it 6 o'clock last night? The sun's starting to set. It's really starting to get cold, and we're glad to be at our home for the night. And then going to the next slide, I think at this point we're going to go to the outside of the tent, go away from the PowerPoint presentation, and Gerardo is going to talk about, okay, first of all, okay, they're pointing over here to another model that Gerardo is going to describe, and then we're going to go outside of the tent, and he's going to show you interesting features about this part of the road section.
There's too much glare.
So I wonder if you want to put the computer over here, move the computer here. We'll let Gerardo. Still pretty glary?
A little bit of glare. Yeah, that's good.
This was a model that Lin do for us. It showed the ascending to the Huanchangan. Is the way of Incas solve the problem of erosion. They put
Still 10 minutes.
10 minutes, okay, we're good.
They put stone pavement and also steps to reduce the velocity of the water in order to avoid erosion. But from Payahuanchangan to this point, we also find a lot of section pavement with the stone, with other proposed. The soil in this part of the road are very wet, so very unstable also. They put pavement to facilitate the pass of the people person for their animal for their also a very lot of drainage system.
Okay, we're going to move now and show you some of the drainage structures in this area as well as the roads.
I know, but I need this.
Right over here. Right here so they can see.
Yeah, or you can sit down actually. If you can sit down, it's better. Can you sit down a little bit?
Like this one.
Yeah. Talk loudly.
We can find a lot of these channels that allow to conduce the water through the road. In fact, just leaving Payahuanchangan, we find 32 of this kind of channels in about 1 kilometer.
Okay. That's pretty strong.
Wait, okay, that's cool.
Distance between the tunnels? You told me the total number, but what's the distance between them?
Was
You have to talk very loudly. Gerardo.
the total distance was allowed more or less 1 kilometer.
But how far between each one of them individually?
Not possible for us to measure that because the rain, it was strong rain.
Oh, you look good today, my friend.
Okay, we're gonna move to.
I like that smile.
No, actually, now we're moving to a section of paved road, and Gerardo is going to comment a little bit on that as far as some of his the conclusions that we've come across.
Okay, you can see
Shot.
somebody. by foot. We can estimate the size of this rock that was used to pavement. We can imagine that this size of rock weighs almost 50 kilos.
Per
So,
stone.
so imagine this is the weight that one llama can carry out. Is perhaps the weight that one man can carry out. That means that we estimate that for 1 meter of this rope, pavement rope, we need a lot, about 16 pieces of stone. That means that one people need to make 120 trips to get enough stones to build 1 meter of this road.
Yeah.
Okay.
Are the stones on the outside larger than the stones in the middle of the road?
No, there is no something that confirms that the pattern is very irregular.
Thank you.
And the last thing we wanted to show you out here was something that we noticed this morning as the sun was coming up. We kind of looked up the hill, and what we saw, what looked something like a dam, or actually a blown out dam. As you see, you see the little V or notch section there with lots of boulders and stones that have come out. And so we wanted to explore that in a little bit more detail. So a couple of us hiked up there to the top this morning, and what we found was we found a natural lake right behind that retaining wall. And as Basilio was telling us, it's actually a spring-fed lake. And there's one in this area, and there's another, but it's a long ways away. He also said that there were villagers that lived behind the mountains there that would come down and get water from that natural lake. So we were thinking that was actually at one time a dam. They built up the wall there to allow the water to be higher than it is. The lake is actually kind of shallow, is what we noticed, not very deep. So we're thinking that they may have built a dam structure so that the water level would be higher. Another thing of interest, and I wish we had time to show you the photos that we took this morning, but the trail, there's a trail that goes around the inside of that bowl, and that trail is up about 15 feet or so from the water, which would make me think that maybe the water was higher at one time, so that really was a dam. Now, whether it was Inca built, we're not 100% sure. Don't know the age of it, and we're not 100% sure that that's a dam, but it looks like it could be. And I don't know if there's anybody on this webcast that can see up there, if Megan can zoom in a little bit closer, that might be able to comment on, does that really look like a dam? Was it a dam at one time, or was that just all natural? And I'd just like to throw that out as an open question to people in the audience. Over.
Did you have a question, a dam question?
Are we looking at terraces to the right of that?
The road?
No, there are no terraces here. You see the cut in the middle, the diagonal, and then you see this rock fill going all the way down.
It looks like a spillway, almost a rock spillway, that it just all came from above.
Right. Considering the earthquakes and some of the things we saw last year, that earthquake of 1970 or thereabouts was pretty severe, and it could have been a dam that the earthquake finally got it.
Ed, the features that we wanted to show you.
This is
Go
Chris
ahead,
from the Cusco
Sandy.
team. Over.
Yes, Chris. Over.
On our broadcast, we have an actual dam section. So maybe when we show the pictures of our dam, if you all could stay on, you could get a good feel for whether or not your structure could be a dam. Over.
Okay, that's good. I'll have to see the timing and logistics of how long we can stay on your broadcast, but definitely be interested in hearing what you had to say. Over. we've got a couple minutes left of our broadcast.
Ed, we have a question from Ms.
Okay,
Smithsonian.
Smithsonian, any questions?
Hi, you guys. This is Sandy at the National Museum of the American Indian. We have a nice crowd here today of visitors.
Keep that smile.
Okay, hearing none.
Yeah. And be sure to raise your hands if you have questions too. I'd like
Wait a minute,
to know,
Ed. We got questions at the Smithsonian.
I'd like to know, based on what you said about the possibility of the dam, and you're looking at it with the thought of was it pre-Inca, could you talk a bit about how you have been able to distinguish, if you have, between Inca and pre-Inca roads? Over.
That's a tough question, Sandy. It's hard. It's really hard for us to know. I mean, like last summer, we visited some sites that people would say this is clearly pre-Inca, and and it was the stones, were just really old and really worn. But it's really hard. It'd be hard for me to distinguish, what was Inca, what was pre-Inca, and like this dam up there, we don't really know. Was this Inca made or was this actually post-Inca or pre-Inca? Where it's really hard to tell. And maybe Megan could add something.
I think with some of the, these roads, they're known as Inca roads. People call them Inca roads. In terms of differentiating between a road that, say, is a Wadi road, there are clear differences between them. And when you're on them, you can identify that. But beyond that, I don't know if much has been written about pre-Inca roads apart from, say, Wadi roads. Over.
This is Cliff. The other piece is this is a road that connects tombos, and tombos were something that the Inca built. So to try to age or classify the road itself, very difficult. But because it runs between two Inca structures, we're pretty sure it is Inca.
Good point, Cliff. We're gonna kind of wrap up here, and kind of summarize what we've learned about Inca engineering. And in general, we realize that the Incas really understood the forces of nature, and they designed and built based on that. So in terms of, you look at forces of nature like water, can be very destructive, but they were able to deal with it through open and closed drainage channels, as you've seen in some of the PowerPoint slides, and also live. They dealt with water using steps as hydraulic jumps to reduce the energy. Also, they paved sections of road where they knew there was lots of water. They also put backfill behind retaining walls so as not to allow for hydrostatic pressure to build up behind the wall and push it out. They also, one thing we didn't mention was they built roads higher up in the mountains so there would be less water. They dealt with gravity also. They located, we found lots of the quarries up higher in the hills, so they could just pry the rocks off and let the rocks naturally, through gravity, just roll down to their location or close to their location. They built retaining walls with interlocking stones because they knew the gravity would kind of push the slope down, and so they had to make sure that the retaining wall would be tied into the road so it wouldn't collapse. They also dealt with gravity using wider base widths in their walls. Wind. This is something that we saw last summer with the kolkas, or like storage houses for vegetables and food. And these kolkas were situated in areas where there would be natural wind ventilation through the kolka, and also temperature, another force of nature. They used temperature. They placed these kolkas at different elevations in the mountain depending on what kind of temperature they wanted to store their food. So the Incas were smart. They used they understood nature. They listened to nature, and they designed around it. And Basilio, somebody was telling us that it didn't matter where they could put their road anywhere. They understood nature, and they would design the road according to that particular location. As a final thought, I'll ask Cliff to go to the last slide of the PowerPoint presentation, showing the Southern Cross. that was kind of a neat shot for all of us because it's been pretty cloudy and cold for most of our trip. Sun's come out now and then, but this was one night where we actually saw this this constellation for about an hour and a half before it disappeared. So we wanted to share that with the audience and have you enjoy it. So with that, we'll just kind of see if anybody has any questions before we move on to the Cusco team presentation. Over.
We have a question here. Just a minute. What? Mike's on.
Okay. We have a student here. How old are you? 10? A 10-year-old who would like to say about the idea of a dam that the water is apparently dried up and that the rocks are still there. And is that kind of what you were saying? The rocks just took the place of the water. Over.
I kind of missed the question. What would you please repeat the question? Over.
Well, it was more of a theory from a 10-year-old here that the dam that the so-called structure that you're looking at, she thinks maybe was a dam, that the water has dried up and the rocks has taken the place of whatever was there. Over.
I think she's got part of it right. We need to tell her that on the Cusco team coming up next, we have a student with us, a 15-year-old from Santiago, Chile.
Yeah. Yeah, I mean, I wish I could have showed you some pictures of that, but you know, it certainly looks like the evidence of there being a dam there at one time that's kind of blown out. But anyway, yeah, appreciate the question from the 10-year-old. My daughter just turned 10 a couple days ago, so thank you very much for that question. Over.
Thank you, Ed. Are we going to sign off and go to the Cusco team now? Over.
Ed, can you put Dorado on one more time? Susanna just came on. Give me a picture of Dorado, please, first before you leave. Smile.
Say something.
Yeah, it's fine.
Su esposa is watching you, my friend.
Thank you, Cliff.
Gracias.
All right. Signing off.
Okay, we're signing off. Ankash team. Bye.
We're ready, Tim.
Okay, greetings from the Cusco team. We are broadcasting today from a location that is an offshoot of the road to Antisuyu, and the main Antisuyu road that we've been broadcasting from before is the road that leads from Cusco into the jungle. So we have quite a wonderful amount of scenery to show you today. And if Cliff, you switch to the next slide, you'll see what we're going to talk about today. Our outline is briefly just to give you an overview of where we are. We'll talk about our structures that we've seen along the roads, specifically we've seen many wakas along the road, and we have one of our archaeologists to explain that. We've also seen many wall sections, and we have a special treat, at least we as engineers think it's a special treat today, an actual dam and lagoon section of this particular area with outside of Cusco on the road to Antisuyu. So we have a lot of information to show you today, to include the hydraulic basin, what we think is a lagoon, and our engineers will discuss that. Today, we also have some folks that are going to stay on after our broadcast, so we're really going to be testing this teleengineering concept. We have some engineers standing by. We'll actually pan down to our wall section that we believe is a dam. So we'll actually try to get some expert advice. So lots of things that we're doing for this broadcast and testing as part of this particular grant and this expedition experience. I'd like to take this time to thank the National Science Foundation, who is funding our project, in conjunction with the Smithsonian, who has graciously been working with us and helping us with these broadcasts. Just to give you an indication of the efforts that we go through, I know that Ed described what the Ankash team has been going through to bring you these broadcasts. We are at an elevation currently of 3,716 meters. And in order to get our
11,300 feet.
We don't have any burrows. If Jennifer could pan to our burrows, our team is our burrows. So we carry all of our equipment, our satellite dish, our generator. We bring it all up to the site every day and set it up. So that's one of our major challenges, is to get our equipment actually where we need to broadcast. So one of the challenges we had yesterday with our broadcast was we left our hotel, loaded up all of our equipment, and our van driver realized that he wasn't going to have enough time to get us to our site. So he basically left us on the street with all of our equipment in downtown Cusco, and we scrambled and were able to find a cab. Our wonderful archaeologist Kevin flagged down, fortunately, a cab that had a roof rack so we could strap our satellite dish to it. And we were able to bring you the broadcast yesterday, despite the torrential rains and hailstorms that happened during our broadcast. So we've experienced weather difficulties, we've experienced equipment difficulties, and today when we were actually setting up our satellite, one of the fine-tuned adjustments that we need to make to our satellite actually broke. So all of our electronic equipment is working well. It was our mechanical equipment, so we actually had to fine-tune our satellite using all of our team to kind of move the satellite up and down until we got our actual signal. So this is quite an adventure. And if Cliff, you could switch to the next slide, you could see where our 4 broadcast locations have been. Our first broadcast location was in between 2 sections of roadway. Our first broadcast showed an area that had a Spanish colonial road on the that ran along the bottom of the valley, and then the Inka road that ran over the top of the ridge. And Jennifer is now panning to the ridge over which we were broadcasting from our first day. Our second site was located in or very close to the backside of the Amaro Markawasi, and that is a very large waka that is located in this area. And this waka structure that we looked at housed the mummy of Amara Topa Inka. And this particular site enabled his relatives and lots of ceremonial rituals to come and venerate the mummy of Amara Topa Inka. So that was our second broadcast location. And if you can see on the Google map, you can see where our broadcast was. Our third broadcast yesterday was actually from another waka structure that is still in use. And what we found in that structure is that we found several corn offerings and some other flower offerings. Now, we're going to describe exactly what a waka is and the significance of it in a moment. Just trying to get you situated as to where we are within the valley or the landscape above Cusco. Cusco is below us. Last location today, if you, Cliff, if you could advance the next slide, it shows the actual location of our broadcast today, which is above this lagoon area. And the next slide will show, next 2 slides show an overview or a photo of the lagoon area and an aerial view of our lagoon area. Also, Jennifer is currently panning the lagoon area. You can see several sheep grazing down in this area. The sheep have been following us all morning. They helped us set up our satellite dish.
They wandered across the road and went and worked with our other team measuring the terraces in the area. So we've experienced a lot this morning with our sheep watching us. So they've been our audience this morning. Now, this a whole area is on the road to Antisuyu. The basin that you see, the Inka Road, actually ran around the outside of this basin, and we'll discuss that in a moment. What I'd like to do now is to introduce the team of people that we have working with us. We have several people from different universities with different backgrounds, so I'm going to let them introduce themselves. We're just going to pass the microphone around, and we'll start with Camila.
Hi, I'm Camila Besa from Chile, Santiago, Chile. I study engineering in the Universidad Católica de Chile, and today we were measuring some width and height of the terraces over there.
Hi, my name is Rudy. I'm from Piura. I study in the Universidad de Piura, and I work in the hydraulics study, and I see the drainage system.
Good morning. My name is Pedro Escajadillo. I'm an architect. I'm from Piura, Peru, and I am a professor in Piura University. Today I made some sketch and help the people.
Hi, everybody. My name is Nicolas. I'm a high school student from Chile. Today I was taking pictures and helping with some measurements to my friends.
Nicholas, smile. Your mom was watching you.
Smile. Your mom is watching.
Hola, Mama.
Okay, hi, my name is Edgar Rodriguez. I'm a civil engineer, and I work in the University of Piura in Peru. Today we are making measurements about the terraces, and I was taking some GPS points to locate it in Google Earth.
I'm Kevin Flurkey. I'm an archaeologist from UCLA, and I will be, once my mic starts working, I will be helping to interpret and explain some of the features of this valley and the sites around here.
My name is Alexei Branich. I'm also at UCLA, and I'm an archaeologist, and I've been working in this area for a couple of years.
Good afternoon. I'm Tim Becker. I'm a graduate student in civil engineering at Iowa State University, and my role on the team is lead satellite communications. I'm very glad to be here.
Thanks for all your hard work, Tim.
Hi, I'm Jennifer Shane from Iowa State University, and I have been operating the camera, and when we're not operating the camera, helping out the rest of the team on measuring different structures.
Okay, that's our team. And what we're going to do right now is, as I've been saying, that we have been broadcasting. Most of our broadcasts have centralized around the road, and then some of the structures that we found along the road. In this particular area, because we're north of Cusco, what you will be able to see is something different than what the Ancash team is seeing. The roads in this area were more of ceremonial. They were meant to make a statement, and part of that statement and part of that ceremony was the location of wakas along the way. So what I'd like to do now is turn the presentation over to Kevin, and we'll pan around the valley to actually show you a good example of a waka while Kevin speaks. There'll also be some slides that will show you different features of wakas as we move through the presentation. Kevin?
Thank you, Chris. So as Chris was mentioning, this section of the road system in this area is very different from what we've been seeing in Ancash. The purpose of the road is different, the form of the road is different, and the kinds of structures we see associated with the road here is very different. As we broadcasted yesterday from the Waka, as I tried to explain yesterday, and I'll try again to put it into simple terms, essentially a Waka is any location or object in the landscape that is considered to be invested with some sort of power or significance. We talk about these things in vague terms because we have to remember that we're dealing with an empire that's removed from our own cultural worldview by 500 years, and that never actually had contact with the so-called Western world, ironically about a hemisphere east of here until contact. But we need to remember that we're dealing with a very different cultural context here. But essentially, typically in the Andes, especially in this region, what you'll find for huacas are large stone outcroppings, such as the one over here to my left that the camera will pan into now. And what you see associated with these often is large sets of architecture, especially very typically Inca architecture, and you see modification to the stone. The Incas were expert stone workers, and they were able to essentially modify the stone in any way that they liked. If you can go to the next slide for me, Cliff, what you'll see is one section of the stone in the huaca from which we presented yesterday, where it was modified in order to receive offerings. That's part of a natural stone outcropping. That stone was not brought from anywhere else. And essentially, when we're looking at these huacas, to understand what the Inca were trying to do with all of this investment of time and labor into the maintenance and veneration of huacas, the veneration of huacas is something that actually extends beyond the Inca Empire, before the foundation of the empire, for pre-Inca people, both in the Andes and beyond. And it's also a tradition that continues all the way up to today. So essentially, by adding their own architectural signature to these already venerated sites, they were tapping into a very strong cultural tradition that persists, as I said, even up to this day, 500 years after the collapse of the rest of their empire. So another one of the interesting things, as Chris said, about this valley, we're seeing some very different things here than in Ancash. You know, Ed was describing how we saw a lot of very straight roads in Ancash. It seemed to be very uniform in a lot of ways. And as Megan was describing, you seem to find these tambos once every 20 to 25 kilometers. And the whole thing is done in a somewhat uniform way. Well, what we have to remember with that is that that was a provincial road. So that essentially would have been ordered to be constructed more or less all at once and for a singular purpose. The roads that you find in this section, as Chris mentioned, they go towards Antisuyu, which was the northeast quarter of the empire, which extended into the jungle. And as any empire that's ever tried to extend into the jungle can attest, it's extremely difficult to wage warfare against people who are accustomed to living in the jungle, especially if your armies are coming from an area such as the Andes and the highlands. So anybody traveling through this section, as was mandatory for all high-ranking officials, so anybody coming from Antisuyu would have passed through this section, and essentially what they would have seen was a heavily modified area that was visually very striking. So these roads, more than just being conduits to carry travelers and supplies or armies, actually were meant to send a message.
We lost your audio, folks.
Hello, Chris. We have no audio right now.
Hi, sorry about that. We've relocated due to some problems we heard we were having with the audio and video. But yeah, just to continue, essentially what we're seeing here is a very different set of objectives with the construction of the roads in this valley than we would see in a provincial area. This was essentially designed to be an embedded message in the landscape. It's a message of power, it's a message of imperial presence, and it's a message of essentially as we said, the wakas were considered to be powerful or significant in some sort of ritual way. So it's a message of ritual imperial importance. So that explains some of the different that we've seen here. If we can get to the next slide. Cliff, can we get to the next slide?
I changed it to the shelf. Is that what you want?
Yeah, thank you very much. So as we were saying, as a message embedded in the landscape here, you see there that that's a shelf carved into the natural stone near one of the wakas here. And what that shelf was most likely designed to do was to hold architecture. Now, the Incas had a very typical form of architecture that was very descriptive and diagnostic that nobody else really was able to imitate very well. So whenever a traveler would have seen that type of architecture, especially associated with a large site like a waka, they would have known essentially that was the presence of the Incas. And as we've iterated in prior broadcasts, the Incas had a very difficult administrative problem in the fact that their empire lasted a very short time, so they didn't have the weight of tradition behind them for very long, and it expanded over an extremely vast area. And within this area, they encountered many different groups of people who spoke different languages, had different cultural traditions, and they didn't have a writing system or one unified language with which to communicate to everyone. So one of the most effective forms of communication, especially for a group of people who don't have, say, flags, as we're used to in the European tradition, would have been this form of stonework. It would have been diagnostic, and it would have been letting everybody in the area know that that area was under Inca control. So that's some of the more interesting things we see in this valley. We're going to go back to Chris now, so she can describe the very extensive road system that we see in this valley here.
Thank you, Kevin. As Kevin was saying, with the road system in this area, it was meant to make a statement. It was also a way for the Inca to communicate. In the area that we have been working in the past 2 days, it is a section of the road to Antisuyu that has not been reconstructed. It's in its natural state. So Cliff, if you click to the next slide, what you will see is the actual road section the way that we found it. And in this road section, you can see collapsed walls. It almost looks like just a field of stones. And this field of stones is actually collapsed wall sections of both contention and retention walls. And what a contention wall is a wall that actually holds up the road, and the traveler would not have seen that particular section of the road. So the stones that were used in that those types of walls were not very finely worked. They tended to be smaller stones, and they weren't fitted together as well as stones that would have been meant to be seen by the traveler. And retention walls are those walls exactly. Those walls were meant to be seen by the traveler, and they were better constructed with larger stones. Okay? And as Cliff is advancing the next slide here, you can see in the slide the lower portion of the contention walls, and the upper portion showed the retention walls. That was basically how we determined where the road was and how the road moved over the past 3 days. Without a well-defined cross-section, we were forced to look for remnants of these contention and retention walls to define the width of our road. As we moved north through this particular basin area, the road gradually would rise to overlook this lagoon area that we've been discussing. That particular lagoon area, having the road rise above that, required some terraforming. And what we saw was contention walls that were much thicker. And in the slide that Cliff had shown you is the contention wall that was 60 centimeters wide in most places. And what we saw is that was much wider than the other contention walls we saw lower in the valley, where they were not having to hold back as much soil. So this indicated to us that the Inca understood that their wall sections were going to have to increase in width, okay, and in strength as they needed to retain more soil to support the road. So they changed their manner of construction based upon the loads that would be placed upon the wall. So it was very interesting to see the changes in the widths as we moved up into the valley. or up from the bottom of the valley to the top of the lagoon. Hey, the next thing that we saw, Cliff, if you could switch to the next slide, were some andin terraces. And andin terraces are basically terraces that were used to support agriculture. And in this particular slide image that Cliff is showing you, these were the terraces that our team was working on today to begin some measurements to determine slope, to determine the actual width of the platform area where they would have grown things, and also to look at the construction of these terraces. These terraces are actually on a hillside above the lagoon basin, and they sit directly behind the large waka structure that we had focused on earlier. Now, this wasn't the only indication of an Andean terrace in this area. Jennifer is actually, if we move to the next slide, and Jennifer is also going to pan to this particular terrace. This is a large Andean terrace wall on the downstream side of the lagoon that actually pushed back into the area heading down towards Cusco, and the actual walls were used to hold back soil to grow several different crops. So we've seen evidence of terracing. We've also, on a small scale, we've also seen very grand terraces down in this area along this roadway. Much, much different than what we would see in the highland area. As Kevin had stated earlier, this section was meant to make a statement as people walked along this road. So we've seen these terrace structures, so we've been able to see the wall sections, the terrace structures, and how they were constructed, where they were constructed, and the changes in that construction. Now, as we were walking through this area, we came upon, Cliff, if you could move to the next slide. Okay, we came upon the remains of what we believe was a stairway that extended from the top of this particular section of the road down into the lagoon area. So these actual stairs were used as stairways. However, they're so deteriorated that we weren't able to do any measurements other than just what the slope was, and they were on a very, very steep slope, almost of about 10 degrees. As we moved down these stair areas, we began to move into what we determined was a lagoon basin. So Cliff, if you could move to the next slide, and what you will see in this next slide is an indication on Google Earth. The actual pinpoint is where, push pinpoint is where we're broadcasting from, right above the lagoon, looking down. And you can see evidence of two wall sections, a lower dam wall and an upper dam wall that helped to retain water in this area. What we're trying to discern is whether or not these walls could have held back the quantity of water that we believe this basin could have held. If you go to the next slide, and Jennifer is panning down in that area, so you
We lost sound again. Need sound, please.
Actually, we lost the satellite signal from the teleport here too.
I saw Ed signed off. the Spanish tended to use the hydraulics that the Inca had built. Actually, some of the modern construction, the new highway construction in Lima, they found the old original Lima, the Inca drainage channels. They were actually masonry tunnels. When they were building these new highways, they found those fairly interesting. Had to stop the construction a few times, let the archaeologists get down there and do some work. But one of the reasons the Spanish also put their city in Lima was because of what the Inca and the pre-Inca civilizations had done for channelizing the river that comes through Lima and using that same water system. Very similar to what I'm out here in Arizona in Phoenix Valley right now, and it's the same thing. The city of Phoenix is built here because the Indians had channel systems off the Salt River that already set up the way to irrigate the fields and everything.
Lost our video.
We were trying to reestablish contact with the team in Cusco. Jaime, who's in Florida running the satellite parts, working right now. I can see that on my set here.
Yeah, no, the satellite link was lost, and they seem to be coming back now. One second. No, not really. No, their satellite link went down. There's no weather conditions here that would have caused that. We have other systems in the same satellite. We're just waiting for the signal to pick up again.
Yeah, they said this morning there's some of the adjustments they can make automatically, but sound like one of their machines broke, and so they were having to aim the satellite by different team members actually pushing and pulling on the dish itself.
Right. They're coming back now. Their modem now, the satellite signal is back on, so we'll have to wait for them to log back in.
That's Jaime. Yeah. He can tell what's going on.
I'm going to take you to a photograph so you can see. What you see here in the right photo, that blue thing is the cardboard box that's handling that satellite. It's kind of oblong, about a little over 3 feet in one dimension, almost 4 feet in the other dimension. They've got it. Looks like they've got it loaded on a horse. Last year we had it on a burro. It's not very heavy, but it's kind of awkward for them to carry. The team also has to carry a generator because there's no power at those sites, and they have to carry their own fuel out there. I think Iowa State is coming back on right now.
Hello? Are we back on? Can you hear us? We had a problem with our generator. We tried to move it and the power disconnected.
We've got sound again. We don't have video yet.
Yeah. We have to come up with a solution for wireless power.
That would be great because the generator's really heavy. Over. Okay, as the page is beginning to reload to our PowerPoint presentation, I'll continue to describe the dams that we saw. When the pages load, what you should
Chris, I've got
see-
the downstream picture of the lagoon area, and your next slide is a culvert from the hydraulic, the colonial period.
Okay.
The colonial period slide is up now.
Okay, thank you. What we found in that particular section was the evidence of a colonial hydraulic structure. It was in the center of the actual lagoon area. It didn't have any type of stones in it at all. It was just kind of a dug channel. And Donato expressed he felt that it was potentially a channel that was used by the Spanish when they arrived. The next slide should begin to show the actual dam walls, so you can get an indication of what they look like. As we were moving through the lagoon, we came upon these two wall sections. You can see that there's a section in between. Okay, and what I'm going to do is switch my video off now since our other video is on, and you can actually physically see those walls and the actual space between. Now, the next slide, while you're viewing the picture of the live picture of the dam, will show you the dimensions of this dam wall on the side of the dam structure. What we found was the wall was 14 meters long, and it was a curved section. The curvature actually went back very deeply into the soil behind the wall, so into the slope. So it really did look like a wall that was built to retain water. The dam wall was also 2 meters wide, so it was the widest wall that we had seen so far, and it was tall enough. It was about, it was 3 meters tall. So based upon the dimensions of these and the structure of these walls, we feel that it could have retained the amount of water that would have been in that basin. If you switch to the next slide, Cliff, what you will see in this particular slide is a cross-section of the dam. And you can see the actual structural capabilities of this wall. In the interior of the wall section, it's compacted soil with lots of compacted stone, giving the wall additional strength. And also the soil behind it, we took a little bit of the soil sample, tested it out with our hands and a little bit of water to see if there was a high content of clay within that actual wall section. And it was a very clayey substance. Clay soil does not allow water to pass through it very easily. So it takes a while for water to move through a clay structure. So we actually use clay as a core to modern day dams. So what we saw in this particular structure was that, yes, there was incorporation of clay and rock to give it quite a lot of strength and also a retention capability. Now, with this, after we looked at this cross section, our team went into the field and began to take GPS points throughout this particular location. And what we used these GPS points to do was to actually determine the overall depth of the basin and then actually trace the basin on a Google Earth image. So as this page is coming up, you can see that where the watershed is and the GPS points. Now I'm going to turn the presentation over to Edgar, who actually completed this work, and he will discuss more about the watershed and the movement of water, and we'll have Cliff move the slides as he begins to speak. Edgar?
Thanks, Christine. So we studied an hydraulic structure which we think it is a dam. So Camila and Rudy measured 100 points with the GPS on the sides of the watershed. This is what we can see in the slide. The red points represents the walls of stone of the dam, and the white points are the perimeter of the watershed. Can you turn the next slide, please?
You got it.
Okay. Well, it's good to notice that the stone wall at the beginning of the watershed is not complete because there's no wall in the middle of that part. So I can see the slate, but you guys, you can see the shape of the watershed, and we have measured the area, the perimeter, and the volume of water of the lagoon. considering a height of 1.7 meters. So the result is like the volume of the lagoon is 17,000 cubic meters. Next slide, please.
You've got the next slide. Go ahead. We're looking at the terrace with A and B.
Okay. You can see the terraces where we were measuring right now, or before. So in the next slide, there's another. There are more photos about the watershed and the direction of the water. Okay, C means that there was a
Lost your sound. Your video's locked.
We lost them again. The video signal is down.
Ah.
The satellite signal, I mean.
Yeah. So it's a very interesting thing, though, that the Inca, almost like the Greeks talked about water, earth, fire. The Inca was very much involved with water, primarily to grow crops, but then they realized they had to have it to grow the crops. When they talk about Pachamama, they're talking about Mother Earth, kind of like we say today. They would reshape nature, which is what it looks like they've done here with this pool. This is a site, though, that was the preserve of one of the Inca. We call it a king or an emperor. In fact, the mummy was here, I would say, until the Spanish came. The Spanish tended to destroy those mummies that they had. But you see the work that was done here. I'm going to take them. You can see the team in Cusco has taken these pictures and put this together. The Inca didn't have steel. I'm back.
One slide, we're trying to show a drawing that Pedro actually sketched of this entire area that will lead into the next of slides. We'll discuss water. So we just want to finish up your thoughts, and then we'll move to this drawing. You can.
Oh, go ahead with your drawing. We have your drawing now. Go ahead.
Okay.
Go ahead, Chris.
If we could go back one slide, please. This is the area that was surrounding the Waka. It's currently under some restoration by the INC. But if you can look at Pedro's diagram, what you see is the central lagoon area, or the retention basin area. It's kind of an aerial view of this whole structure from the lagoon all the way up to the actual Waka area. Okay, so Pedro has been doing some sketches for us that were giving us some ideas of what the area looked like and indicating where our walls are. So thank you, Pedro, for those drawings. And what you see on the PowerPoint slide is a ritual area that was below the Waka. And what, as Cliff was saying, is that the Inca understood that water was very important, and in terms of watering their crops, and that they needed to get water to different places. They also used water in different ways in around these Waka areas. To provide for relaxation and to have some water around these ceremonial areas. So Cliff, if you could move to the next slide, and I'll just show one drainage port that actually comes out of that water pooling area that would continue to move water down from the drain or from the pool area into the lagoon. So Kevin's going to talk a little bit more about the importance of water to the Inca.
Thank you, Chris. So, as Cliff was just saying, you know, a valley like this is an example of some expert engineering. They were able to essentially terraform the entire area and change the natural form of the valley. And when we think about it in the light of an embedded message in the landscape, you know, it's a large incentive for some of the people whom the Inca expanded out and conquered. You're thinking about, they've got semi-nomadic or nomadic people that they're trying to convince to stay in one place, and if you can convince them that if you stay where we'd like you to be, we can bring you water, potable water to keep you healthy and to keep you hydrated, and water for your crops in order to allow food to grow. So that's a strong message that a valley like this tends to send. So associated with most of the wakas here, including the one just up the valley that we were showing earlier, is an element of water control. And so you'll see, Cliff, if you can go to the next slide for me, please. If you see there, what you've got there is actually a large staircase that on first glance you might think that it's for people to go up and down the Waka, but actually at the top of it and at the bottom of it, you've got canals and pooling structures. So what that is definitely was meant to be a visual and audio effect that was created by the control of the flow of water. So you see these in all these places, and again, there's a message embedded there that the Inca have control over water, which in an area like the Andes means that they have control over the power of life. They can grant or deny access to water in your area. So that's one of the biggest things that we see looking at there. The carved shelves, again, would have reminded anybody who's there enjoying this experience of the controlled flow of water and this large laguna here at the bottom of this basin. There would have been a reminder there that it's the Inca that did this, and it's the Inca that control this area. And so essentially this would have been a strong message and a strong incentive for the continued loyalty and obedience to the empire. So that's one of the things that we've been learning to look at here in this valley, is seeing this architecture, seeing these roads as something other than simply functional uses of the engineering expertise of the Incas, but in fact actually have serving social and governmental functions.
One of the things that we noticed in these Waka areas with a lot of these carved shelves or these areas to contain worked stone was that the Inca would actually offset or frame the Waka so that people would know that, again, it was an Inca area that you were moving through, and to remind the travelers that were moving, or the people making their pilgrimages to Cusco, that this was the way, and that the Inca were basically here. It was their flag. So the road was, in terms of an overall road structure, it really was a language for the Inca, and a lot of their carved structures and their work stones were a flag to show that the Inca were here, and that it was their empire that was changing these earth structures and working with this rock. At this point, what I'd like to do is open it up for any questions. Does anybody in the audience have any questions for us? Over.
do?
The pointer's in the right place.
So just do it?
Well, let's see what
Smithsonian, you have any questions?
no, go ahead.
Can you hear me? Over.
Loud and clear.
Hi, guys. Thank you again for a wonderful trip that we all would love to have taken. I wanted to ask you two things about water. One is, and you may have covered this, and I was faced a different direction, but I want to know what the difference might be between a lagoon, which may be man-made, and something that might be called a reservoir. I mean, not a lagoon, natural, man-made reservoir that would be a purposeful place to capture water. Is there any difference? And then I have one more question after that. Over.
Kevin and I have been conferring here, and what we believe is that a laguna like this that was potentially a combination of both natural and man-made sorts of structures. I would say that this area, and in terms of comparing it to a reservoir that would have actually been built specifically to hold water, to store water, I think the major difference that we've seen is that in this area it was more of a statement that they could control the water, and based upon the fact that it was in between two wakas, that it also showed some control of water. Kevin, want to add anything?
Yeah, the other thing about the region, especially this valley right here, is that this is one of the areas that I've seen most full of these waka sites. So anybody traveling through this area would have known they were in a ritually significant area. So this lagoon right here actually may have contained some sort of a message about the power of the Inca state religion, which, as we have mentioned in earlier broadcasts, the implementation of that state religion was one of their primary means of control and means of integrating the cultural experience of people from throughout this entire empire.
Jose, are you still there? I know you and I have discussed this quite a bit. This is Cliff. I've discussed this quite a bit. And the Inca understood nature, but the Inca also liked to remodel nature to suit its own terms. And I think these sites, particularly here close to Cusco or something like that, like y'all been saying from the site out there, Chris, that this is a statement.
He's not over. Well, go ahead and push it right there.
Okay.
And say, can you hear me?
Can you hear me, Cliff? Over.
Right.
Oh.
Try it again.
Go ahead, Jose.
No, Cliff, the audio is pretty weak here, so I couldn't quite hear your full question. Was it relative to state structures versus less important structures on the road? Over.
It's the idea that the Inca understood nature, Pachamama, but at the same time, the Inca would change nature, the shape of the landscape, to make a statement.
Yeah, absolutely. I think the monumentality speaks to both to the monumentality of the Andes. You know, just about anything you do of any resonance has to be monumental. But certainly they love to signal, indicate their presence wherever they were. I think the road itself, as Dr. Flores likes to say, the road goes as far as the empire, not 1 inch more and not 1 inch less. It was the indicator of the extent of the empire. And everywhere where monumentality could be expressed, I think they did. And of course, the high mountain sites for military surveillance as well. Over.
Any other questions, Smithsonian?
Yes, this is Sandy again. Some of the current scholarship states that the Inca may have used cutting off people's waters as a military tactic, such as the Chimu. What do you think of that? Over.
Yeah, Sandy, that's a great point, and that's one of the points I think that could have been made by by the presence of a lagoon such as this. Like I said, the control over water goes both ways. It's not just that the Inca can provide for you, but it's that the Inca can also prevent you from accessing the water that you need. And that's another means of control and another large statement of power. As I mentioned, this is very close to the road to Antisuyu, which is a very typically contentious area. This is true of all empires that have tried to expand into the jungle. The jungle is always a difficult place to control. And so a message such as this, which would have been visible so close to the primary route to and from the jungle, definitely would have been a strong statement that we control the water, and where we want the water to go, it goes. And conversely, where we don't want it to go, it doesn't go.
How's your weather today, Chris?
Lost
Well, since we're not shivering and water's not dripping off my nose, it's wonderful.
Much better.
Everybody is smiling today, and the sun is shining, and it's beautiful today. Over.
How is Rudy? Is he doing better?
We have another
Rudy?
question.
Rudy?
Over.
Buddy, ¿cómo estás?
Chris, we have another question. Over.
Okay. Go ahead.
Are the terraformations that you found there, are they just a sign that are found in and around Cusco, or are they found in the outer regions of the empire? And if so, what are the farthest that you've found some outside of Cusco?
Over.
It's a good question. As far as how far away you can find them, that might actually be something better answered by the Ancash team or by Megan, who has traveled a large section of the road. I don't know if they're still on. But one thing that we definitely know for sure, especially looking at the sections that they've been traversing versus what we see here in the valley, is you see a much higher concentration here. Again, a likely reason for that is that one of the strategies for the imperial integration and control that the Inca utilized was a mandatory pilgrimage to this site. So they knew that people from all corners of the empire were going to see this area. So if you're going to concentrate your monumentality and your terraformations, you're going to do it here. Now, that doesn't mean you don't see incredible terraformations and incredible adaptations to the landscape in more provincial areas, but you're definitely going to see a higher concentration here.
That answer your question?
The terracing goes to the civilizations that are pre-Inca. The Inca, though, were very good at building with stone and controlling water, as we've discussed here. And so you see it in the Sierra. I mean, if you want to grow crops, you got to have some kind of flat land, and the Sierra is vertical, so that's the only way you get flat land. It's also what we were talking about, like the Greeks, the wind. When we talk about fire, we're talking about light. They knew which side of the mountain to give them enough light so that they could, and warmth so that they could grow crops. The terracing will reflect that knowledge about growing crops and light.
Yeah, Cliff, that's an excellent point, especially when it comes to the terracing. What you see a lot around the Sacred Valley and around Cusco here is terracing that actually likely wasn't used necessarily for growing crops because its access was still somewhat inconvenient, but it was actually put all up and down mountainsides simply, again, to demonstrate that the Inca had the power to do this, that they could set up land for growing crops just about anywhere they liked. So yeah, that's another testament to the monumentality and the terraforming ability of the Inca Empire.
Smithsonian, any other questions?
No, not right now. We've reached the end of our broadcast, and we'd like to. Does Chris have any more final words you'd like to say? Over.
I just wanted to thank the Smithsonian for working with us, and also thank the Ancash team for an excellent broadcast, and also the audience there for the good questions that you asked today. And hopefully you were able to see what we've been seeing and what we've been experiencing here with some degree of clarity, and hopefully we've helped you understand a little bit more about the Inka. Thank you for the opportunity. Over.
Thank you, Chris, and thank you, Ed, if you're still on the line. And Cliff, thanks for your help during the broadcast. Thank you. Bye.
Is Jay still on?